In this video, I will discuss about full subtractor circuit. Full subtractor circuit is a logical circuit which is used to subtract three binary numbers or binary bits. So already we have studied half subtractor circuit, where half subtractor will subtract two binary bits, whereas full subtractor will subtract three binary bits. Let me show with block diagram. So we have the full subtractor. So it has three inputs. So let me assume A, B and B borrow input are the inputs. Let me assume these three are inputs, and it produces two output known as difference and borrow. So I will use the variable D to represent difference and variable B to represent borrow. So here these two are outputs. So now let me implement the full subtractor circuit. So for that I should write the truth table first, then we have to get the Boolean expressions. Let me write the truth table. So this is the truth table where A, B, B in are the inputs, difference and borrow are the outputs. So here we have three inputs. The possible values are 0 to 7. That is 0, 0, 0. We have 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, that is 4, 1, 0, 1, 5, 1, 1, 0 and 1, 1, 1. So let me represent decimal values. That is 0, this is 1, 2, 3, 4, 5, 6 and 7. Let me write difference and borrow. 0 minus 0, 0 minus 0, it gives 0 as difference and 0 as borrow. So 0 minus 0 is 0, 0. That 0 minus 1, it gives difference as 1 and borrow as 1. That is 0 minus 1, difference is 1 and borrow is 1. Similarly 0, 1, 0. So 0 minus 1 gives difference as 1 and borrow as 1. That 1 minus 0, it gives difference as 1 and borrow as 1. Similarly here 0, 1, 1, that is 0 minus 1, difference is 1, borrow is 1. Borrow is 1, that difference minus 1 is nothing but 0, that is 0, 1. So 1, 0, 0, difference as 1, borrow as 0. 1, 0, 1, that is 1 minus 0 is 1, 1 minus 1 is difference is 0, borrow is 0. Here 1, 1, 1, 0, that is 1 minus 1 is 0, 0 minus 0 is 0, that is difference is 0, borrow is 0. Here 1 minus 1 is 0, 0 minus 1 is 1, if borrow as 1. Now I will find the Boolean expression for difference and borrow. So for that I will use K-map. Let me use three variable K-map. Let me take difference first. So here the variables are A, B, B in, that is this is A and here it is B, B in. As we know in K-map we have to write the cell numbers like this 0, 0, 0, 1, 1, 0, 1, 1. Here it is 0 and 1. The cell numbers corresponding decimal values are 0. This is 1. This is 2, 3. We have 4, 5, 6 and 7. So now let me write the values. So in difference column here we have 1, which is with respect to decimal number 1. So in cell number 1 we have to write 1. So here we have 1, that is 2, and here we have 1, that is 4, and here we have 1, that is 7. In cell number 7 we have to write 1. So rest in all other cells value is 0. Now let me simplify this Boolean. Now let me simplify this K-map. So here we cannot make any pair or quad or octal. So all ones are independent. We can take it as individual values. This is 1. The value of this will be A, B bar, B in bar. A, B bar, we have B in bar. So with respect to this one, the value is, which is A bar. Here it is B bar, B in, B bar, B in. So with respect to this one, corresponding row value is A and column is B in. That is B in, and here we have one more one. The value of this will be A bar, and here it is B in bar. B in bar. So therefore I can write the difference equation for difference. D is equal to, we have A B bar B in bar, plus here we have A bar B in, plus we have A B in, plus A bar B in bar. So this is the difference equation of full subtractor. So this is the difference equation. If you implement the difference equation, we need more number of gates. So I will try to simplify this further. So here I can represent this as D is equal to, here the B bar term is common. I'll take B bar term as common. I can write it as A B in bar, plus here we have A bar B in, plus similarly here I can see B is the common term, that is B. It will be A B in, plus here we have A bar B in bar. Further I can simplify this as it is B bar. Here we can see that A B in bar plus A bar B in is nothing but A XOR B in, plus here we have B. So A B in plus A bar B in is nothing but A XOR B in. A XOR B in. So now let me assume A XOR B in is equal to some other variable, say Z. So I can represent this D as D is equal to B bar Z, plus here we have B, it is Z bar. It is Z bar. A XOR B in is Z. Here we have complement, that is Z complement. So this is nothing but D is equal to, here this is nothing but B bar Z plus B Z bar is nothing but B XOR Z, or I can write D is equal to B XOR Z. Z is nothing but A XOR B in. A XOR B in. So therefore the simplified difference equation is D is equal to A XOR B XOR B in. So now to implement this, we need only one 3 input XOR gate, or we can implement using two XOR gates. So now let me write the Boolean expression for borrow. So I can write for borrow. So the variable input variables are A, B and B in. We have 0 0, 0 1, 1 0, 1 1, 0 and 1. The cell numbers are 0, 1, 2, 3, 4, 5, 6 and 7. So now therefore here we have 1, that is 1, 2 and 3, 1, 2, 3 and 7. So in 1, 2, 3 and 7 we have to write 1. In all other cells value is 0. Now let me simplify this further. So here with this one and this one I can make a pair. So value of this will be, it is A bar. Between these two column common term is 1. 1 is with respect to B in. So this one and this one I can make one pair. So value of this is, again it is A bar. In between these two cell common term is 1, which is B. And this one and this one together I make one more pair. The value of this is 1 1, that is B in. Therefore I can write the carry expression as, borrow expression as P is equal to, we have A B in plus B in plus we have A bar B. this is the borrow expression. So now with the help of difference and borrow, we can easily draw the circuit diagram. Let me draw the circuit diagram. Now let me draw the circuit diagram for this. So difference is A XOR B XOR B in. Let me take 3 input XOR gate. So the inputs are A, B and we have B in. The output of this is nothing but difference D, which is A XOR B XOR B in. Here we can also use two XOR gates, one for A XOR B. Output of that can be used for another XOR gate B in. So that is also fine. So difference is done. Now we'll take B, that is borrow equation. So here we have A B in, B B in and A bar B. So we need one AND gate for this, one AND gate for this, one AND gate for this. Total we need 3 AND gates. Let me take one AND gate. Here the inputs are A and B in. So let me take A and B in as the input. This is A and this is B in. So output of this is A B in. So then we have B B in, that is, let me use another AND gate. Here the inputs are B and B in. So this is B. B in is already available here. This is B in and here we have B. This is B. Output of this is B B in. Then we have A bar B. I need one more AND gate. So input is A bar and B. That is, we have A here. Let me pass A through one inverter. Output of this is A bar. So A bar is connected here into B. So B is, this is B. So this is B. The output of this is A bar B. Then we should use one OR gate. Let me use 3 input OR gate. So one input is this, that is A B in. Next we have B B in, then A bar B. This is A bar B. So output of this is borrow. So this is the complete circuit diagram of full subtractor. Now I will try to implement the full subtractor using two half subtractors. So already we have studied the half subtractor circuit. With the help of half subtractor, I will try to implement full subtractor. So now let me implement full subtractor using two half subtractors. So already we have derived the expression for D, that is A XOR B XOR B in. So already we have written the Boolean expression for borrow also, which is A B in plus B B in plus A bar B. So now instead of using this Boolean expression, I will write the Boolean expression for borrow with the help of this truth table. That is, I can write the borrow expression as, here we have 1, so the corresponding values are 0 0 1. So it can be represented in terms of variables as A bar B in, that is A bar B in, plus here we have 1, the corresponding inputs are A bar B in bar, A bar B in bar, plus here we have 1, that is A bar B in, A bar B in, and here we have 1, that is A B in, plus A B in. Now let me simplify this further. That is B is equal to, now compare this expression and this expression. So here I can take B in as common term, that is B in. So here it will be A bar B bar plus here it is AB. Similarly, if I compare these two expressions, I can take A bar B as common term, that is A bar B. Here we have B in bar plus B in. So let me simplify this further. B is equal to, we have B in. So A bar B bar plus AB is nothing but A XNOR B, and here it is B in plus B in bar is nothing but 1, that is A bar B. So now let me use this borrow expression to implement. So now let me implement this difference first. So for difference we have A XOR B in. So let me use one XOR gate. So the inputs for this are, say, A and B. The output of this is A XOR B. A XOR B, and we have XOR with B in. Let me use one more XOR gate. So one of the input is A XOR B, another input is, we have B in. So output of this is difference, which is equal to A XOR B XOR, we have B in. So now here we have A bar B term. Now I will try to implement borrow. Here we have A bar B term. So for A bar B I need one AND gate. I'll take one AND gate. So input is A bar, that is, this is A, pass through inverter. The output is A bar, this is A bar, and we have B. So this is A bar B. So now here we have B in A XOR B in complement. So here this is A XOR B. So pass through this through inverter. So output of this is A XOR B inverter. So pass through this through the AND gate, because here we have A XOR B dot B in. So I need one AND gate. Another input is B in. This is B in. So now output of this and this should be connected to OR gate, because here between there is plus, it indicates OR gate. Let me use one OR gate. So let me use OR gate. One input is this borrow, another input is this. So output of this is B. So which is nothing but, we have A XOR B, and another input is B in, plus here we have A bar B. A bar B. So here we can observe that this XOR gate, AND gate and inverter is one half subtractor, and here this XOR gate, inverter and AND will together form another subtractor. This is another subtractor. So thus we have implemented this full subtractor using two half subtractors. Thank you for watching.